identities. But before that, let's go over the basic trigonometric identities once more. Okay. So what are the basic trigonometric identities? The first one is that the sum of squares of these two t ratios is equal to 1. That sine square theta plus cos square theta is always equal to 1. Okay. And we have a couple of more trigonometric ratios which can be deduced from this ratio only. If we divide the whole equation by sine square theta, let's say first we divide by cos square theta and then we divide the whole equation by sine square theta. What we will get is divide by cos square theta. So this will become sine square theta upon cos square theta plus cos square theta upon cos square theta is equal to 1 upon cos square theta. Now sine upon cos will give you tan. So this is tan square theta plus 1 is equal to sec square theta. So this is the first derived trigonometric ratios from this basic trigonometric identity, which is sine square theta plus cos square theta is equal to 1. And the second one will be 1 plus tan square theta is equal to sec square theta. And if we divide the whole equation by sine square theta, this will become 1 plus cot square theta is equal to cosec square theta. Okay, so you have to learn these three trigonometric identities by heart, that sine square plus cos square is equal to 1. Okay, now this can be rearranged and asked something like this: 1 minus cos square theta, what is this value? So that will be equal to sine square theta. And similarly in this case, that sec square theta minus 1 can be written as tan square theta, and similarly cosec square theta minus 1 can be written as cot square theta. Okay, so these are the basic identities, but I want you to learn two more identities by heart. The first one is sine to the power 4 theta plus cos to the power 4 theta. This can easily be solved, but I want you to learn that this value is equal to 1 minus 2 sine square theta cos square theta. And this is very easy to deduce that how will you get this value? This can be written as sine square theta plus cos square theta whole square minus 2 times sine square theta cos square theta. And subsequently this thing will become 1, and that will give you 1 minus 2 sine square theta cos square theta. Okay. And similarly, I want you to learn the value of sine to the power 6 theta plus cos to the power 6 theta. That this value is equal to 1 minus 3 sine square theta cos square theta. Okay. So it's better if we simply learn this three basic identities, because they can be used directly in the questions. Okay. Instead of calculating every time, we can simply do this. Okay. This is very easy to remember also, that sine to the power 4 theta and cos to the power 4 theta, that will be equal to 1 minus 2 sine square theta cos square theta. While in the case of 6 theta, here in case of 2, it will be 3. Okay. So next, let's move on to the addition and subtraction formula. Okay. So what is the meaning of addition and subtraction formula? That if we try to add two angles in a trigonometric ratio, let's say sine of a plus b. What is the value of the sine of a plus b? This is not equal to sine a plus sine b. Okay. This is a very common mistake which people do. But this is not equal to sine a plus sine b. That distributive property is not applied here. Okay. What will happen is, if I want to find this value, this will be equal to sine a multiplied by cos b plus cos a multiplied by sine b. Okay. And similarly in case of sine of a minus b, we can say that we can just shift this plus sign with a minus sign. Okay. So wherever we are writing plus, we'll change it to minus. So this will be equal to sine a cos b minus cos a sine b. Similarly, if I want to see the value of cos of a plus b, that will be equal to cos a cos b minus sine a sine b. Similarly, cos of a minus b, that is equal to cos a cos b plus sine a sine b. Okay. So what's happening in case of sine of angle A plus B, if I'm adding two angles in a trigonometric ratio which is sine, then what will happen is I have to multiply sine of first angle with the cos of second angle and cos of first angle with the sine of second angle and add these two. In case of subtraction, I have to subtract these two. But in case of cos, this is a very different concept. In case of cos, I have to multiply cos of both the angles altogether and sine of both angles. And then in case of plus A plus B, cos of A plus B, this will be a negative sign. Okay. In case of cos of A minus B, there will be a positive sign. So if instead of remembering all these four formulae, you just have to remember it's something like this. That in case of sine of A plus minus B, this will be sine A cos B plus minus cos A sine B. Okay. The first formula is of addition and the second one is of subtraction. And similarly, in case of cos of A plus B, there will be a negative sign. In case of cos of A minus B, there will be a positive sign. Okay. So we can remember it something like this. And if we try to divide these two, what will I get? If I try to divide sine of A plus B with cos of A plus B, I will get tan of A plus B. Okay. And that will be equal to sin A cos B plus cos A sin B upon cos A cos B minus sin A sin B. After simplifying and converting all these trigonometric ratios into tan, okay, I will get a formula which is tan of A plus tan of B divided by 1 minus tan A tan B. Okay, so the formula for tan of A plus B is equal to tan A plus tan B divided by 1 minus tan A tan B. Okay, and similarly, if I want to see the formula for tan of A minus B, in that case, all the plus sign will change to minus and the negative sign will change to positive sign. Okay. Similarly, as we did in the case of sin theta and cos theta. Okay. So these are the three addition and subtraction formulae which you will have to learn by heart. Okay. And how did we get this formula? We just divided these two. Okay. If you want to prove it, then I can do it for you. The tan of A plus B will be equal to the division of these two. So that will be equal to sin A cos B plus cos A sin B divided by cos A cos B minus sin A sin B. Now what I will do is, I want this formula in the term of tan. Okay, so I cannot introduce sin A and B over here. Okay, I want these things as tan. So what will I do is, I will divide the numerator and denominator by cos A and cos B. So what will happen if I divide this expression by cos A cos B? That the cos B will cancel out and this will become tan A. Similarly, in this case, cos A will cancel out and this will become sin B upon cos B, which is actually tan B. And in this case, if I divide it by cos A cos B, this will become 1 and this will become tan A tan B. Okay, so what we did is, we divided the numerator and denominator. We divided numerator and denominator by cos A cos B and we got this formula. Okay, so we have to learn these three formulae by heart. And similarly, if we learn the plus formulae, we will easily get the minus formulae by changing just the positive sign into negative sign and vice versa. So by these, let's do one or two more very important results. By using these formulae, we'll try to find out the value of sine 75 degrees. Now, as we know that sine of 90 minus theta, will be equal to cos theta. Since in the case of 90 degrees, okay, when we are dealing with this 90 degree or 270 degrees, our trigonometric ratio will change. Okay, sine theta will change to cos theta, cos to sine. And since it is the first quadrant, this will remain positive. Okay, so sine 90 minus theta, we know that it is equal to cos theta. If I substitute the value over here, that theta is equal to 15 degrees, this will become 75 degrees and this is equal to cos of 15 degrees. So we can say that sine 75 degrees is equal to cos 15 degrees is equal to, let's apply the addition formula for sine. We can write it as sine of 30 degrees plus 45 degrees. Right? We can do that. And we can apply the addition formula over here, which says that this is equal to sine 30 degrees cos 45 plus cos 30 degrees and sine 45. So we simply get the value of sine 30 degrees is 1 upon 2, and this is equal to 1 upon root 2. 1 upon 2 multiplied by 1 upon root 2 plus root 3 upon 2 into 1 upon root 2. So this value comes out to be root 3 plus 1 upon 2 root 2. So we know that the value of sine 75 degrees will be equal to root 3 plus 1 upon 2 root 2. Okay. Similarly, I am writing down these results over here, that sine 75 degrees is equal to cos 15 degrees is equal to root 3 plus 1 upon 2 root 2. Similarly, we will try to find out the value of sine 15 degrees. Okay. How will I get the value of sine 15 degrees? If I subtract the two angles, which is 45 degrees and 30 degrees, I will get the angle 15 degrees. Okay. And I will apply the subtraction formula over here, which says that this is equal to sine 45 cos 30 minus cos 45 sine 30. Okay. And this expression will come out to be root 3 minus 1 upon 2 root 2. So we can say that sine 15 degrees and sine of 15 degrees will be equal to cos of 75 degrees because of the complementary angles concept. This is equal to root 3 minus 1 upon 2 root 2. And these are two very important concepts which we need to learn. Okay. Similarly, can we get the value of tan 75 degrees or tan 15 degrees? Yes, we can. How? In case of tan 75 degrees, we can see that tan 75 will be equal to sine of 75 upon cos of 75. Now, the denominator in case of sine 75 and cos 75 is common. Okay. So we can simply write it as root 3 plus 1 upon root 3 minus 1, and if we rationalize this, we will get this value is equal to 2 plus root 3. Okay. And simply, in case of 15 degrees, this value will come out to be 2 minus root 3. Okay. So we can say that cot 15 is equal to tan 75 is equal to 2 plus root 3, and cot 75 is equal to tan 15 is equal to 2 minus root 3. Okay. So, let's do a simple question on this addition formula. So the question is, you have to find the value of cos x plus cos of x plus pi by 3 plus cos of x plus 2 pi by 3. Okay. Now we know that in case of cos, the addition formula is a bit different, and we'll try to apply what are the addition formula in case of cos. This will become cos x, okay, and the formula over here will be cos A cos B minus sin A sin B. Okay, this is simple, that cos of A plus B is equal to cos A cos B minus sin A sin B. Similarly, in this case, the same formula will be applied, and this will become cos of x cos of 2 pi by 3 minus sin of x sin of 2 pi by 3. Now the angle x is unknown, but we know the value of sin and cos of 2 pi by 3. Okay, we'll substitute the value of cos pi by 3 and sin pi by 3. Cos pi by 3 means cos 60 degrees. Okay, and cos 60 degrees is equal to half. Similarly, sin 60 degrees is equal to root 3 upon 2. And this is cos 120 degrees. Okay, and we know that cos theta is negative in the second quadrant. Okay, so this will be equal to minus half. Okay, but sin 2 pi by 3, since sin theta is positive in the second quadrant, this will be written as sin of pi minus pi by 3, which is equal to sine pi by 3 only. So this value will come out to be minus root 3 by 2. Plus root 3 by 2, but with a negative sign, this will be minus root 3 by 2. So if we simplify this, this will be cos x plus half of cos x. Okay. And this is minus root 3 by 2 sin x. Okay. And this value is minus half cos x minus root 3 by 2 sin x. Okay. So this is clear. Now we will get this value. These two will cancel out and this will become cos x minus 2 times root 3 by 2 x. So after simplifying, this will become cos x minus root 3 by 2 root 3 sin x. Okay. Now we can further simplify this by a method, okay, which we will learn in the next lecture, but I will give you a glimpse on how we simplify this further. Since this expression cos x minus root 3 by 2x, this was the result we got, half cos x minus root 3 by 2 sin x. Okay. Now if I want to convert this into a single cos, single sine or single cos, okay, a single t ratio, what will I do? I know that this is the value of cos of pi by 3 and this is the value of sine of pi by 3. Okay. So this expression will become the formula 2 times cos x cos pi by 3 minus sin x into sin pi by 3. Now this is the formula cos A cos B minus sin A sin B. So this can be written as 2 times cos of x plus pi by 3. Okay. So this is what we got by deducing it further. Okay. Now in the next lecture we'll learn about the multiple and submultiple angles.